Hey there, super solvers, and welcome to This Explainer. I am absolutely thrilled to have you here today, because we're about to unlock a serious mathematical superpower. If you've ever looked at a really tricky math problem and just felt, completely stuck, well, get ready to completely flip your approach. Today, we're not just doing math, we are becoming full-blown math detectives.
So let me ask you a question. Have you ever been staring down a problem from a contest like maybe Math Kangaroo, and suddenly you realize, wait, there isn't just one simple answer here. There are a bunch of possibilities. It gives you that immediate sense of uncertainty, right? You're kind of left wondering what exactly happens when a math problem has more than one answer, and how on earth are you supposed to track them all down without getting completely lost?
Well, that brings us to Section 1, the detective's secret weapon. Because honestly, every good detective needs one.
When you're facing a complex, tangled-up mystery of a problem, Casework is the ultimate tool you want in your detective kit to crack the case wide open. So, the crucial point here is that Casework is simply the process of splitting a problem that has lots of possibilities into smaller, much more manageable pieces. And we call those pieces cases. You solve each piece individually, and then you just put everything back together at the very end. Instead of trying to swallow a giant mystery whole, we're basically breaking it down into bite-sized, easy-to-solve pieces.
Let's look at Section 2, 3 steps to solve.
Now, obviously, every successful detective needs a reliable method. You can't just guess wildly and hope for the best. To truly master casework, you've got to use our 3-step blueprint. Step 1, look for the what if. These are the elements in the problem that can change or vary. Step 2, make separate groups or cases. Now, it's absolutely vital here that every single possibility belongs to its very own case. No overlapping allowed. And Step 3, solve each case separately, and then simply combine your answers. It really is just that straightforward.
Moving right along to Section 3, solving number mysteries.
Let's dive into this by taking our new detective skills right out into the field. We're going to start with some foundational number puzzles just to test out how casework operates in action. Think about this first mystery. It says, I am thinking of a number. When I add 5 to it, the answer is either 9 or 11. What could my number be? Now, what's really interesting here is that word either. We don't know for sure if the total is 9 or 11. That is our exact point of uncertainty, our what if, and it tells us exactly how we need to split our cases.
So here's how we build our solution. Let's make case A where the sum equals 9. So some number plus 5 equals 9, which means our number has to be 4. Piece of cake. Now for case B, where the sum equals 11. That number plus 5 equals 11, so the number just has to be 6. By dividing the problem up, we confidently find our 2 final answers. The number could be 4, or it could be 6.
Okay, ready for another one? Here's your second mystery. Find all whole numbers, 0, 1, 2, 3, and so on, that make this statement true. Some unknown number plus 7 equals an even number. I want you to mentally pause and really ponder this for a second. What kind of number gives an even total when you add an odd number like 7 to it?
And this right here brilliantly illustrates the sheer power of casework. We can literally split all whole numbers into just 2 simple cases, odd numbers and even numbers. Let's test it out. In case 1, we test an odd number. Let's try 1. 1 plus 7 is 8. Well, 8 is even, so that totally works. In case 2, we test an even number. Try 2. 2 plus 7 is 9, but 9 is odd, so that case completely fails.
Because we systematically checked our cases, we can confidently declare the solution. Any odd whole number, 1, 3, 5, 7, 9, and so on, is the correct answer. We just proudly solved our second case, completely eliminating any guesswork. How cool is that?
All right, on to Section 4, real-life math puzzles.
You guys are doing amazing so far. Now, it's time to level up our detective skills a bit. We're moving from pure number games to real-world objects. Things get kind of tricky when we have to start translating word problems into math clues. But the great news is, our casework strategy stays exactly the same. Let's investigate Mia's apple mystery. The clue reads, Mia has some apples. Twice her apples is more than 5, but less than 13. Her apple count is a whole number. How many apples could she have? Translating this directly into a math clue, it means that 2 times her apples must be exactly 6, 7, 8, 9, 10, 11, or 12.
Now, when you have 7 different possibilities, organization is everything. Setting up a table is a total game changer. We can set up our 7 cases in a first column for 2 times apples. Then, in the middle, we just divide by 2 to find the number of apples. And in the final column, we check our firm rule. Is it a whole number? Organizing it this way makes it incredibly easy to spot the winners. Cases with 7, 9, and 11 result in decimals, so they instantly fail, which means Mia can only have 3, 4, 5, or 6 whole apples.
Let's roll right into a classic competition puzzle, the wheels puzzle. A parking lot has tricycles with 3 wheels and bicycles with 2 wheels. The total wheel count is 12. And here is the sneaky clue you absolutely cannot miss. There is at least 1 of each. So how many of each are there? We have to be really careful with that at least 1 rule as we start building our cases.
So how do you actually organize your scratch paper for a puzzle like this? Well, we build our cases around the tricycles. Case 1, 1 tricycle takes up 3 wheels. That leaves 9 wheels, which would mean exactly 4.5 bicycles. Nope, that's a fail. Case 2, 2 tricycles take up 6 wheels, leaving 6 wheels left over, and that perfectly equals 3 bicycles. Boom, that works. If you run through the rest of the possibilities, case 3 gives another weird decimal, and case 4 leaves us with 0 bicycles, which breaks our at least 1 rule. So we've definitively proven that only case 2 works. 2 tricycles and 3 bicycles.
Next up is Section 5, Games and Shapes.
Okay, let's dive right into this next phase. For our final set of field missions, we're going to look at how Casework applies to slightly more advanced scenarios involving games, combinations, and even geometry. Imagine you're rolling 2 dice, 1 red and 1 blue. How many different ways can you get an even total? Remember, each die shows the numbers 1 through 6, right? We need the final sum of the 2 dice to be an even number. How do we break this down without having to manually write out dozens of individual rolls? That would take forever. We use our Casework logic, of course. Case A is when our first die rolls an even number. Since an even plus an even equals an even total, the second die must also be even. There are 3 even numbers on the first die and 3 on the second, so 3 times 3 gives us 9 ways for case A. Case B is when the first die is odd. Well, an odd plus an odd also equals an even. That's another 3 times 3, which is 9 ways. Add them together, and we have 18 ways in total. Fast, simple, and perfectly logical.
Now let's see how this builds into geometry with a shape puzzle. A rectangle has a perimeter of 12 centimeters. The length and width are whole numbers. What are the possible lengths and widths? What's really interesting about the core math here is, if the perimeter around all 4 sides is 12, then just 1 length plus 1 width must equal half of that, which is 6. And naturally, the length is always going to be greater than or equal to the width.
Once again, Casework beautifully organizes the possibilities for us. We set our cases based on the length being 6, 5, 4, or 3. But wait, notice case 1? If the length is 6, the width has to be 0 to equal a total of 6. But a width of 0 isn't a real rectangle. Casework helps us safely catch that sneaky little trap. We cross it out, leaving us with our 3 valid rectangles, a 5x1, a 4x2, and a 3x3, which is actually a perfect square.
Finally, let's go over Section 6, the detective's checklist.
Huge congratulations, Super Solvers! You have successfully cracked every single case file today. But before you head out on your own, we need to quickly go over the detective's checklist to make sure you never make any rookie mistakes out there in the field. Here are your 4 golden rules of casework. Number 1, no overlapping cases. Every possibility must live in one and only one case. Number 2, cover all possibilities. Don't leave any stone unturned. Number 3, check your answer strictly inside the rules of that specific case. And number 4, combine everything nicely at the end. Remember, organizing your thinking through this checklist is the absolute key to feeling totally confident, especially when you're taking on high-pressure math competitions.
Which brings us to the end of our explainer. From now on, whenever you look at a math puzzle and catch yourself thinking, well, I guess it depends, you know exactly what to do. You have the superpower to break it down and logically solve absolutely anything. So the only question left for you is, now that you're a certified math detective armed with the superpower of casework, what mystery will you solve next?